Okay, welcome to our weekly video lecture. And I think this week we're just going to do chapter 7. We're going to not go on to 8. We're still going to be a week behind, but we'll try to catch up at some point. Okay. So first thing I wanted to look at, there's some people that had some questions about the homework. Okay. So it's due tonight, but as you know, I usually give you a little extra time if you need it. Okay, so that shouldn't be a problem. One thing I do want to say that I've got some dental work I have to have done tomorrow, so I'm not going to be able to Zoom for sure tomorrow, maybe not Tuesday. Should be back by Wednesday, I would think. Don't know what it's going to entail and how long I may have trouble speaking clearly, but shouldn't be too big of a deal, hopefully. Okay, so yeah, so if you have questions, go ahead and text them. I think that's the best way to go about it. And also you could post them on Moodle to the forums, and we should be able to go from there. Okay. So let's take a look at these homework from chapter 6 examples. Okay. And at some point, once people have turned them in, I can go ahead and put real versions of this out there if somebody wants to. Okay. So let's look at 6:15. So this is C6P15. Okay. And does need a public static void main. Okay, what doesn't it like? That's weird. I haven't had this problem in the past. I'm not sure why I'm having a problem now. Looks okay now. Hopefully it is. Okay, so the main thing on this, so this one is asking you to look at the hypotenuse calculations. Never spell hypotenuse. Hypot, T-E-N-U-S-E. I don't know what I did wrong. Not going to worry about it. Does it know what I did wrong? Oh, it didn't. Okay, good. So it's just being done. Okay, if that's wrong, then I'm just wrong today. Okay, so anyway, with this one, most of these in general, it wants you to create a function or a method. They call them methods. Okay, those methods have to be down here. Again, it doesn't ask for a class. When you read the problem, it asks you to take this method, okay, then put it into an application. So we're not dealing with public and private and all that stuff. Okay, we're not developing another object. We won't need a test program. The test is going to happen in the main. Okay, so we are going to do a public function, and they say to call it hypotenuse, Hypotenuse. It still doesn't like it. Okay, so the hypotenuse function, it's a public static. Okay, so it's going to be a static function. It's static because we're not creating instances of this class. Okay, so they're all going to be public static. Hypotenuse. And with this one, it's going to calculate the hypotenuse of a right triangle when the lengths of the other two sides are given. Okay, so it's going to take two arguments of type double, and it's going to return another double. Okay, so it's going to be a public static double hypotenuse that's going to take a double A and a double B for the two sides. Okay. Okay, and what's it unhappy about? Yeah, it has to return the result, right? Okay, so all we're doing here, okay, so incorporates method into an application that reads values for side 1 and side 2 and performs the calculation, okay? So we can use the math POW and the math SQRT, okay? So we know that because we're doing the hypotenuse, we know that a squared plus b squared is equal to c squared, okay? So we have a squared and b squared, so we're just gonna, if we want to do a variable, we can do a double h if we want, okay? We can set h equal to, okay? And I'm just going to put it on here, and then we're going to kind of go from there. So we want a squared. So that's a math.pow for power function, okay? And I want the number a 2, okay? Let's see if that makes it happy. Okay, it does. So it's going to be that plus b squared, which is math.pow b 2, okay? And I'm going to take, to get c, I have to do the square root of that. So I can just do, I could do it all in one big line. Let's do it that way, which is kind of ugly. It's going to start there and end there. I can do all this with a square root. I do math.sqrt of all that stuff. Okay. And then when I've done that, I'm just going to return the h. Okay. And that's really all we're doing as far as the function. And you can test it. I may have made a mistake. I'm just doing it on the fly. Okay. Then up here, you're going to test it in this program. Okay. So it's going to, what does it say for it to do? That reads values for side 1 and side 2. Okay. So all you can do here, you can do a double side 1, side 2. Okay. And then you normally want to ask the user. That's what I would do. But let's do a side 1 is equal to 3. Side 2 is equal to 4. Those need to be 0.0. Just be. So, I mean, they'll do an upcast anyway. But let's make it clear. Okay. Then I can do a system.out.print line on name of our function. Hypotenuse, that's going to take side 1 and side 2. Okay. And if all that worked, which it may or may not, this should print out a 5. Let's see if it does. Oh, there's an error. What doesn't it like? Oh, I don't know why it said that, because it gave me the correct answer. So yeah, I don't know what it's doing, but I put it a 3 and a 4 and I got a 5. So that's the basic idea for that one. Okay. And then 520 on the area of the circle, the same kind of a deal, right? We're going to create another function. So you have it'll be a different program entirely, of course, but it'll have its main. The main will call the function for circle area, which just takes in a radius, returns the area. And that's all we're doing for those. Okay. The other one on this section was the 625, and people had some questions about the prime number problem. Okay, so for on that one, we're testing in kind of a brute force fashion. Okay, so we're going to have a function down here that, and I'll add it to this, although of course it wouldn't work here. So again, it's going to be a public, it's going to be a static, it's going to be a Boolean, okay, is prime, okay, and it's going to take some int, whatever, okay. So that's how we're going to set these up. And then you're just going to have to basically loop through. And it gives you some parameters here. Okay, so look through from that number down, doing a mod to see if the mod equals 0. This is the basic idea. So you're going to display all the prime numbers less than 10,000. Okay, so you go ahead and loop through. You're basically starting at 1, at 2, sorry, up through, and then problem C gives you either n divided by 2 or the square root of n or whatever, which you can limit that if you want, but if you can just go all the way from 2 to n if you want. And each time through, you're going to use the mod with the percent sign to see if it evenly divides. If it does, then that's one of the factors. That's not prime. Okay. So as an example, if you're up to 4, okay, it's going to start by asking if 4 mod 2 is equal to 0, then basically not prime. Okay. Else keep going. Okay. Or in this case, it's a bool, so we're just going to return. At that point, we don't have to do anymore. We can do return false. Okay. Probably not else. Then you're going to go on to the next loop. So that's the idea there. Okay. Then up here, you're just going to loop from 1 to 10,000, and if the number's prime, you print it out. If not, you don't. That's all we have to do on this. Okay. So hopefully that makes a little bit more sense. So now let's talk about the new stuff in chapter 7. Okay, so the main thing this talks about, and this chapter, like many of their chapters, has some odds and ends kinds of things about it. Okay, But the first idea here is just we're going to create arrays. So arrays are our first data structure. So a data structure is a way to put together a homogeneous data or the same kind of data, so ints or doubles or whatever, into a format that we can easily store things and get things back out of. Okay. So we often think about an array would just be consecutive numbers somewhere. Okay. So that's usually how it works, certainly in C++, probably in Java kind of hides from it, but so you're going to have, so think of like a row, like an Excel row on a spreadsheet with cells there, okay? So you're going to have up to so many that you can store the data in, okay? So we can get to any of those array positions directly, so we have random access, okay? There's a picture on page 260 in my book that shows that. It's basically starting with an array called C, okay? So C at the 0 position will have in it like a -45, okay? And then C at the 1 position would have like 6, and so on, okay? All the way down. Of course, this is not good code. All the way down to, in this case, there's a C11, okay? Which has something else in it, doesn't matter. Okay. So the point is, and don't worry about all the X's and the errors there, but the idea is that we're going to create the structure to hold so many items of whatever type, okay? And then we get to those starting with 0 is the index of the first one, and then 1 for the index of the second one, and so forth, okay? So let's look at how we're going to create one of these. So let me go ahead and just get rid of all this craziness and start a new one. So we're going to do File, New, Class. Okay, we're going to call this one Array Test. And we do want a public static void main. Again, we're making an application. Okay. So this is just going to be some, fun with arrays. Call this. So to declare an array, okay, I can do the following. I can say int bracket bracket. It's going to be an array of integers. The name's going to be C. It's going to be equal to a new. New is what allocates memory. Int of size 12. Okay. So this is going to create an array called C that has up to 12 items, all integers, from C0 up to C11. Okay. So you can do anything you want. They're just an integer. So I can say C0 is equal to 5. That's good. I could say first C11 is equal to something. Again, it always starts at 0, goes from 0 up through 11. Okay. So I can do that. I can also do an array of strings if I wanted. Okay. So I could say string, and again, I put the square brackets to let it know that it's array. B is equal to new string 100. Okay. So you can do that as well if you want to create a different array. Okay. So no, you can break this into pieces if you wanted. I could say int C there, and then I could say C equals if you wanted to. If you want to break up where we're, because the int C basically names it, but it doesn't have a space in memory yet. This second line, C equals, and the new is going to create a space for it in memory. Okay. So if you want to initial an array, you also have the ability just to put things in right as you go. Okay, so you can do them all at once. So you could say something like, and this code's going to be a mess, as you know. It's going to be an int, call it array. It's on a keyword, oddly enough, but you do have to have your brackets straight. But only that many of them. Well, only that many of them. Okay, so I can say int array, arrays the name, equals, and then start putting in numbers, arrays, whatever, or integers. Okay, and when you do that, it's going to determine the size by how many you put in there. In this case, array sub 0 would point to 32, array sub 1 would point to 45, array sub 34 would, array sub 2 would point to 34, and array sub 3 would point to 67. Okay. If you wanted to print out such an array. Okay. You could do the following, and I'm on page 263. I could do a system.out.println, sorry, printf. And the printf is using some things I don't think they've talked about, but we're going to do a string %s, okay? Then we're going to do a %8s, which is going to be eight spaces we're allowing for that string, okay? And then a new line character. And then we're going to do the word index. And then we're going to do for the second string, the third string, I guess. No, second string. We're going to do the word value. Okay, and all that was also in quotes. Okay, so this is going to say index, and then it's going to give us 8 spaces for the word value. Okay, and then it's going to do a new line character. So this formatting is a useful thing to know. Okay, and that messed it up somehow. I don't know how. That should be okay. Why is that not okay? Do I have too many of these? Oh, I have too many of those. There we go. Now we're good. And just see what that does. Not much. I don't know what it thinks is having. Yeah, it doesn't like something about my project, but it's still running. Who knows? So here's the index, but then it gives us those 8 positions for that. Okay. And then we're going to loop through for as follows. We're going to say for an int, call it counter, equals 0. That's our initial condition. As long as counter is less than, every object knows its length. So there's an array.length that's going to return the integer length of the array. Okay. I can do counter plus plus. Okay. And then just do a system.out.printf. This time we're going to do a %5 for a 5-digit for the counter. Okay, that's the D, followed by a %8 D for the value, and then a new line character. We're going to fill those in with the counter and with the array at position counter. Okay. We run this one. Again, I don't know what it thinks there's an error in my project, but anyway, we'll just ignore that for now. So basically that's what we're doing there. We've got, here were the numbers that I put in, here we're just putting those out. So that looping through is a good thing to be able to do. Okay. The book gives some other examples here. You can go through on figure 7.4 is calculating the values we place in the array elements. We sum it up in 7.4.4 and 7.4.5. We're using a bar chart, not really a bar chart, but one we're kind of making up with asterisks to do that as well. Okay. There's another example in section 7.4.6 on using the elements of an array as a counter. Okay, so that's going to go through, and we're going to do a roll of the dice class. Okay, that's then in its main function going to have a array called frequency, and it's then going to roll the dice, and it's going to put it in depending on which number it is. It's going to add to its own array count, basically. Okay, so that's just an example of using the arrays. And 7.4.7 is using arrays to analyze survey results. Okay, same kind of a deal. Okay, the 7.4.7, and they show it to us and then explain it. It's on page 269. Is going to do something that we haven't seen before. So let's talk about this. Okay, so I'm going to wipe out this. And this stuff's really, really not going to work now, but it'll be okay. Okay, so in this case, we're going to have for int answer is equal to 0. This is only part of the program on page 269. Answer is less than responses.length. So responses is going to be our array. Answer plus plus. Okay. So the new thing we're going to do here is we're going to do a try. And this is part of the error correction or error handling that we do in Java. Okay. And what we're going to try, so I guess that's the end of the try. The try is going to try to do something. And if it can't do it, then we're going to be able to do something about it. Okay. So I'm going to do plus plus frequency responses answer. Okay, 2 brackets there. Okay, so I'm going to try to do that. Okay, and I don't have any of this set up, so it's going to give me an error. But if I go to do this, and it turns out that I've gone too far, okay, and I've gone out of bounds, okay, I'm going to do a catch. If there's an error, I'm going to catch it. If there is no error, it's just going to keep on going on. The error I'm going to catch is the array index out of bounds exception. And I have the name E to hold that error. Okay. So if we get that error that we're trying to access a position that doesn't have a response, then it's going to put us into this category. Okay. And in this category, then, an E is going to hold the error. Got to get the brackets going the right way. Open bracket. Okay. Then in this catch, we're going to do a system.out.print line on E. Okay. And that will give us just the error that we've had. Okay. And then we do the system.out.printf. Well, we don't care about that. That's just going to print out more stuff here. Okay. But what this E is going to do for us is this E is going to call, most objects have a toString method, which will return a string representation of the error message. And this will print out on the screen when there's an error. Okay. And it shows that in the book, how to do that. Okay. So this try catch block is a good thing. We're going to run into a lot of errors as we go along. And with those errors, we're going to be catching them so it doesn't just blow up the program. Okay, that's the point. You don't want the program to blow up. Okay. 7.6 is a case study on card shuffling and dealing simulation. Again, that's a good program to type in. I'm not going to go through it here, but if you read it, type that in, you should get that. And it shows how we're dealing with arrays, some of the things that we're doing there. Okay. Something else we can do when we have an array, and again, I'm only going to put partial code up here just to see what we're doing here. So let's assume that we have an int array equal just some random numbers, 56, 87, whatever we got, 21, 37, good enough. Okay. If we have those, that's all that's in our array. Okay. I can then do the following. I can say for, it's a specialized for loop. Int number is a variable that's going to hold it, colon array. Okay. What this is going to do is going to iterate for us all the way through. So I can say total is equal to total plus number, or total plus equal number if you like that way. Okay. So what number will do the first time, and I think it's probably clearer here. This should actually run, I think. If I do a system.out.print line on number. Okay, it's going to get what that number is as it goes through. So what doesn't that like? Oh, it needs one more of those. Yeah. Okay. So again, what this number is going to do, what this for loop is going to do, the first time through, number will be 52, then 87, then 21, then 37. Okay, so you run that, that's what you get. Okay, so that's, you don't ever have to do that. The other loop we did before would work just as well, but this is just a shorthand. Okay. Section 7.8 talks about passing arrays to methods, and you can certainly do that. If you do that, you just have to make sure that in your function, so let's say we're going to go down here and create a new function. It's going to take an array. So I can do a void function. Let's say I'm going to call it modify array. Okay. It's going to take an array of doubles that we're going to call B locally. Okay. Then once you've done that, you can send an array of doubles to that function, and it's going to deal with it just like you would expect. Okay. Examples of that as well in the book. Okay. Section 7.9 talks about the whole pass by value or pass by reference. And Python goes somewhere in between and does I forget what they call it, pass by something, pass by object, I forget. Python does weird stuff. But anyway, most languages have where you can either pass in the value of a parameter or an actual live copy to the memory address of that variable. Okay. So this is one of the areas where Java is trying to protect you from yourself. So Java does everything a pass by value. So if you've done C++ programming, you're always putting in constants everywhere to make sure that things don't get changed because you're passing in live memory addresses. In Java, you're not. Okay. So that section's more if you're used to other programming languages, you don't have to worry about it. Okay. 7.10 is a case study on a class gradebook. Again, those are worth typing in and looking how it's going. Okay. 7.11 talks about the idea of multi-dimensional arrays, or matrices we sometimes call them in mathematics. And the point is here that you can have an array of pretty much anything. It can be ints or doubles, but it could also be employees if from the employee class, or accounts or dates or whatever we've done. Okay. It could also be an array of arrays. Okay. And an array of arrays means that the first element of an array is a whole other array. And if we do that, we're going to be able to get a two-dimensional array. Okay. So again, there's a picture on page 286, figure 7.16, where we start in column 0, row 0 at A00, 2 brackets. Okay. So again, if I wanted to just put that in here again, it's not going to like it. Okay. I could do, for example, A00 would reference the first row and the first column. Okay. So probably doing an example here that makes more sense would be the better way to go. Okay. So for example, we could say in our public static void main, we have an int like this. It's two-dimensional. Array 1 is equal to, okay, so 2 of these. So the first row is 1, 2, 3. And the second row is 4, 5, 6. Okay. So in that way, you don't have spaces, but you should put it to make it look nicer. Okay. So once I've done that, oh, missing a bracket. That should be happy. Okay. So now I can system.out.print line anything from array 1, 0, 0 would be a 1 to system.out.print line array 1. Okay, it's 0, 1, 2. So 2, 2 would be the 6. Okay. I'm out of bounds somewhere. 0, 1, 2. How am I out of bounds? For length 2 at line 8. Oh, I only have 2 rows, 0 and 1. Now it should be okay. Yeah. So column 0. So this is this has 2 rows, 3 columns. Okay. So it goes from 0, 0, which is 1, to 1, 2, which is 6. Okay. So there'll be 6 different items here. 1, 2, 3 in the first row, 4, 5, 6 in the second row. Okay. So it also goes through, if we wanted to print that out, once we've got that, you would need two loops. You'd have to loop for the row or the column, and you really have a choice here what's going to go first. So I could do example for int row equals 0. Okay, row is less than array.length. There's args there, what I want there to be. Okay, row plus plus. There's no function there either. Okay, that's my outer loop. And I can do a for call equals 0 as long as call is less than array 1 here, array 1 dot just length. I get length, losing my mind. Length. Okay. Array 1, it's in this one, the inner one is going to go all the way to the length of the first array, okay, which is going to be row, array 1 row. Okay, so this is going to be, this will be the go to 2. The length of this array is 2. The length of this array here is going to be 3. Okay, and then call plus plus, not there. And that killed all that. 1, 2, 3. What have I done now? Bracket, 2 brackets there. Bracket, bracket. I love when you get crazy on the keyboard. It's getting late. 1, 2, 3, 4, 6, right. Okay. So I'm going to go up to the length of that because array 1 sub or bracket row is just another array. It's the 1, 2, 3 array. Okay. Get the length there and then do the call plus plus. I didn't start that off with a parentheses for some reason. Okay. So inside of that, I can do that one. Then here I'm doing system.out.printf. Do a %d space. Close that. And then you want array 1. So sorry, array row call. Array 1. Declare this one as an int. Yeah. And that should print things out. 1, 2, 3, 4, 5, 6. Okay. So we also go through in 712, and there's another case study on a class gradebook that's going to use a 2-dimensional array. Should look through that as well if you're having trouble with this stuff. Okay. Then we get to just some kind of weird stuff that they throw in. 713's on variable length array arguments, and one of the homework problems has you do that. And all we're saying here, we're doing a function. We'll just create a new one down here. So they've got public, static, double, average. Okay, it's going to take a double, dot, 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 and then numbers. Okay. And when you do this, okay, then numbers becomes an array of all the numbers they sent in. Okay. And that's a decolon. No, public set, what a, no, no, just that. That's what it is. Yeah, and then we can come down here and define that. Okay, so, something like that. Oh, I haven't returned a type yet. Okay, so then when you do this, numbers becomes an array. Okay, and I would do this up here by saying something like, and again, I wouldn't have all the other stuff. I would just say something like average 1, 2, 3, 4, 5. Then that numbers array would become the 1, 2, 3, 4, 5. Okay. There's also an example in 7.14 where we're going to use the command line arguments. And since we're doing our clips for this, it's not going to be the same thing. So it's probably not something I want you to test necessarily. But just so you know, the idea is this string args is what comes in if you were typing in from the command line, Java space, whatever the class name is, and then some other values after that. Okay. So it's worth reading through 7.14, although it's not easy to do in Eclipse. Okay. And then the chapter kind of closes out with some other things that are kind of built in. Okay, so there's a Java util array class out there. That's a bunch of built-in functions for you. It's got sort, binary search, equals, fill, how to copy arrays, so all that stuff. Okay, so that's very useful. So you don't have to roll your own. Sometimes you want to roll your own, sometimes you don't. So there are examples of using that on page 299, okay, in the textbook. And then there's also on 7.16, which I believe is the last section of the book, this predefined data structure is called collections that we have. Okay, so one of the problems with the normal arrays is that normal arrays, you have to set their size and you can't expand it. Okay, so you can't add more to it later. So you have to know how many you're going to have or make the number bigger, which causes some inefficiencies. Okay, so that's why we have this collection called array list, and array list allows you to make it bigger if you want to. Okay, example of using that again on page, it's figure 7.24 on page 303. Okay, again, we're not going to do the GUI stuff in 7.17. I think there's enough going on without that. Okay, so that's it. So read through the arrays. Let me know if you have questions about any of that stuff. I think it's worth typing up the examples in the book verbatim, not the bits and pieces like I did. Run them, see what happens. See if you can get them to work. Use those as examples for the homework. Okay. Okay, so it's Sunday night, so Monday I'm going to be out of contact mostly, I would guess, but that'll start changing come, I'm guessing, Tuesday. But at any time that you want to send a message, if you have questions, let me know. And I'll either respond via video for everybody, or I'll respond to you in particular, or I'll do something. We'll figure something out. Okay. Okay, so that's all I've got for this week. So everything should be posted. Let me know if you have any questions.